We're rolling. Martin, hi, nice to see you.
Yeah, hello, Daniel.
Welcome back to my podcast.
Yeah, it's been a while, I think, hasn't it?
I checked this morning, almost 6 years.
6 years, so that means it was probably just before COVID.
No, actually, we did it sometime in June 2020. Yes, then we accepted. So right at the peak back then. Yeah, crazy. And well, what happened in those 6 years, and especially what happened in the last 3 years? From a mathematical point of view, I talk a lot about exponential growth these days. A lot always happens in a short period of time. In my lectures, I often say you just need to keep saying the same thing long enough until it turns out to be true. Breakthroughs in the AI field, the latest possibilities, and it's great that you're here today. We actually have so much to discuss, which of course we do. In retrospect is different than it used to be, which I also think is good. Of course, I also brought some questions so that you can pull out short clips and then share them on social media afterwards, because not everyone listens to or watches a podcast for a whole hour. Those are also great opportunities. We can also talk about that right away, about your experiences from your teaching, microlearning. What about attention span? The first thing I'm curious about is this. I remember introducing you back then as the coolest professor in Germany, which is what people called you. You also tried to try new approaches relatively early on, whether with YouTube videos in general. Earlier, we talked about computer games. For heaven's sake, gamification. We still have to talk about that. Serious games. You tick off one term after another, but above all, you experiment a lot and get a lot done. And earlier, we also talked about Christian Spanagel, greetings to him at this point, who also
Greetings to Christian.
tried an incredible amount of things. To start with, what's been happening with you over these past 6 years? What I'm really curious about, of course, is the degree program we talked about in the live stream, by the way, where we met a few months ago and then said, come on, let's talk in person.
If you can't meet in person, at least connect on social media.
But that led to another live talk here on site. So what kind of course did you develop?
Well, I think it actually started about 6 years ago. So not long after our conversation, when a few of us said, let's just sit down together. Take a blank sheet of paper and think, what would a degree program actually have to look like today if we gave ourselves all the freedoms we wanted to take? Because a traditional lecture, which is already over 500 years old, yes. Yes, and we should really think about whether this format is even remotely up to date anymore and what we would actually like to do differently. So we spent, I think, about 1.5 years working on strategy and of course also thought about how we could actually get started in practice. Then we got an experimental status, and then we started the degree program, which is called Mechanical Engineering, as you know it, but with the subtitle, so to speak, Product Engineering and Context. We probably don't need to go into detail now. Sometimes it sounds more spectacular than it is, but I would say it is radically different, because I would say the core idea comes across quite well if we look at the first 3 semesters. We have 1 module per semester. It's not divided into countless small modules or anything similar. And when the guys and girls start, we put a technical component on the table for them. For example, a robotic lawnmower. And the task is, by the end of the semester, you understand it and have ideas on how it could be modified from a sustainability perspective. And then there are no lectures, but instead they are assigned several academic coaches to support them. I coach them, and not just in the first semester, but throughout their entire studies on the subject of chemistry and materials engineering. And then they also get a bit of input. We talk about what they actually need to look at, Also, where do you get information from? Where do you get reliable information from? Of course, it's not that you can't talk to an AI in between. Of course, they also notice the instructional videos from them. They also go to the library voluntarily and so on. And then it goes like this. They regularly contact me and say, Professor Bonnet, do you have another 2 hours to come by? We already have so many questions again. And then we discuss the questions together. And most of the time, they don't get any answers from me. I just ask questions back. And they realize that they actually find their own way to the answers together. And of course, that's really exciting. And so they're divided into small project teams and they're not left alone there because there's also something called a reflection component. That means there are colleagues who come more from the social field who talk to them about it first. What is it all about? How do you approach a project? What roles are there in such a project team? Doing tests with them. What type am I actually? Reflecting on that, reflecting with the groups on how things are going regularly, reflecting with individuals on how things are going, and so on. So that's just as an introduction to what the basic concept of this degree program is. And of course, it actually has relatively little to do with a normal course of study.
That's really exciting because if I understand it correctly, there must, of course, be a prerequisite for this to even be possible. We've now gone through the centuries, as you said, so the classic lecture is actually quite old, but of course it comes from a time when you really had to read things out loud. You have, let's say, as a key technology, a book.
Yes, and where the professor was the source of knowledge.
Exactly.
That was the only source where you could get knowledge. Absolutely. That's the core that has changed over time.
Of course, the technological prerequisites have to be in place for you to be able to offer it that way. And then, of course, the next question is, how do you evaluate that scientifically, if you like, to make sure it actually works? Because it sounds so nice that everyone learns in their own way. One person watches another video, another one, let's call it active learning, gets a coach by their side. You know, that's a big change. You need to have time for that, and then others need to have time too. Do you maybe have an AI coach with you? Where do you find the materials? How do you check that? Which platform do you use for that? Maybe a bit more specifically after all.
Yes, of course.
That you're now saying, okay, you already have graduates from this.
So we've been doing this for 3 years now. And the people who are now in the practical phase are at top companies worldwide. And they're only getting applause there because they don't just have theoretical knowledge with no connection to practice, but they've been doing project work from day one. They see a problem and then they know how to approach it. That means they go into the industry and are ready to go. But the question was, how can you monitor that? How can you basically ensure quality as well? Yes, yes. So for one thing, because it's such a big topic, the reason why you do it is not just because we think it's better, that you learn better this way. That's definitely true. But also because, of course, the requirements for graduates today have changed massively compared to the time when I graduated, especially the whole topic of agility. The requirements are changing almost daily. And I have to be able to react to that. That's why we're using a Scrum concept adapted for universities. There's also a product owner and so on. And we do these kinds of sprints. That means there are small subtasks for the big assignment, and then they also present them. They then have to present as a group what they have done in the last 2 weeks, for example, and what the progress is. And then, of course, as coaches, we can also ask a few silly or critical questions about their progress, just to get them thinking again about where they might be heading in the wrong direction, where things could go, and so on. But then, already in the first semester, and certainly by the second and third semesters, they also have to produce artifacts. Of course, they have their own small room. They don't need lecture halls anymore. They have a room where they can spend time. Small areas for each group. but they also have a kind of mini maker space. So an area where they have 3D printers, tools, testing devices, measuring equipment, and so on. That means they tinker there with their Arduinos, they print things, they program things. They also have a coach for programming. They have one for math, one for physics, and one for mechanics. And that means they come here and, for example, have built a mobile robot that has an attachment at the front, drills a hole in the ground, then changes the tool, reaches back, takes a seedling, and plants it in the soil. Then it moves on. That's essentially how reforestation was addressed, for example. Entire areas are then automatically reforested or whatever. The wildest things they come up with all start with the question of what this mobile platform could be used for. Of course, controlled by AI, guided navigation. So in some cases, they also have a camera. They drive over an area, see where a crop plant is, and that one gets fertilized. And where there is a weed, then poison is sprayed there precisely so that you don't spray the crops with poison, but only the weeds, so to speak. Anyway, so they have to understand the AI, they have to program the whole thing. Of course, again, partly with the help of AI, but you also have to understand the architecture, of course. But then you also have to somehow get the fluid there. That means you have to deal with fluid mechanics, with the motors, with sensor technology. Then you have to build the arm. For that, you need mechanics. Then what materials do I use to make it? For that, you need materials engineering and so on. Because they have a problem and they have to solve it somehow, and they want to solve it well, and it has to work in the end too. So they gather the information. But you also mentioned, so to speak, researching it and evaluating it. We have, TH Köln is already quite strong when it comes to innovative teaching methods and also researching our own teaching. Yes. That means that was considered from the beginning. So there are people, and I have already published about it as well, with a colleague who, for example, is responsible for mathematics there. I looked at this first semester and thought, what would I actually do with my traditional degree program? And I basically set the 10 chapters to 100%. That's the knowledge I convey. Yes. And then I reflected, what have they been dealing with now? And then I went back through those chapters. And then I have chapters where they did the same amount. I have chapters where they only did half. I have chapters they haven't looked at yet. And then I have chapters where they probably did, let's say, 250%. So they went further than I would go in the master's program because they just really got into it. Well, this was about the plastic chassis, and then the phenomena, and also what additives are actually needed to withstand environmental conditions and so on. You would never teach that in the first semester, but that was exciting, interesting, and relevant for them. So they really dug into it. So that's not the same. But of course, looking back, I asked myself, well, who actually defines what 100% is? Am I still teaching the right content? Because what I mean by that full 100% is what you traditionally teach in materials engineering or materials science. The curriculum has basically been the same for 100 years, I'd say. Yeah, now they've added a bit more on plastics and a bit more on ceramics. But overall, you start with lattice types, lattice defects, phase diagrams, iron-carbon diagram, blah, blah, blah. It's always the same old stuff. I think all of that has its relevance, but the question is, does that actually still reflect professional reality? And because of that, through these studies, I was actually encouraged. I thought exactly that if you balanced it now, the result would be the same, but the chapter weighting was completely different. Although I was actually questioned a little bit. And with me, of course, my whole community of materials engineering professors, are we actually still teaching the relevant things? Because the topic of plastics, for example, is so huge and is still mostly just an add-on. You can do it, but you don't need to.
And tell me about assessment. I'm trying to make it tangible now because we're getting to that. Of course, that's still from a system where you say, okay, I'm going to study now, and then I go from semester to semester. And then I'm also taught things which I ideally also apply. Then I take exams so I can see whether I have understood it or not. How does the student, or how do they know, or how do they make it measurable? Do they take exams? Do they test themselves?
Is there
Platform?
No, so that's why I had a look at your latest book here, So Geht Schule, and I was really impressed because right in the introduction you lay out the first, 8 points or so about what it's actually about. And I could just check, not for school but for university, but then just replace child with student and it fits. And with us too, there's a lot more portfolio work happening, portfolio work. So as I said, they give their presentations and then there are questions asked. You really get a sense of them because I actually have conversations with them. I can give some direction there. And yes, we've always defined certain minimum standards. That means I can have an oral conversation with them afterwards. And then I say, guys, if I ask you about this now and we really can't have a conversation about it, because you still can't extract the information from this material name, for example, then it doesn't work. You have to be able to talk to people. That means you need to know some vocabulary or at least have a feel for some really important material properties. What is the modulus of elasticity as a measure of stiffness, the yield strength? You have to calculate with those later, and if I haven't understood at all what they're actually supposed to tell me, then even doing the calculation won't help, or rather, I won't be able to evaluate the result of the calculation. That means this is sometimes already checked in oral conversations, and then they say, well, you need to look into that again and make sure that it works.
In the past, it used to be like this. You took an exam, handed it in writing, and then you got a 1, 2, 3, or 4.
Or you just failed.
Or you got failing marks, but you don't do that at all.
But instead, very, very occasionally and rarely, but actually, let's say we want to move away from that. But the project,
The project then decides whether you complete the project, because if you complete it properly, then you must have understood these individual components as well.
Right. Well, I mean, the only thing is, of course, that you're just a small group. And of course, we want to make sure that no one from the rest of the group just gets dragged along and actually hasn't understood anything themselves. That means, of course, they are briefed from day one and in the first few weeks, almost daily or at least weekly on that. Because, of course, on the one hand, they should work effectively. That means, yes, one person dives deeper into the topic, another does research here, and the next one does research there. But still, of course, there has to be an exchange of knowledge on a level where you can say, okay, this is what everyone should have taken away at the very least. That means and of course, it's a lot of fun to see that because I think that's also something you've been talking about for a long time. Also, one or all of the great thinkers who have thought about the topic of learning, if you are able to explain it to others, then you have understood it. Yes. So if they also think, yeah, okay, now I get it from the way Susie explained it to me, then Susie understands it. And that's exactly what happens, meaning they pick up the knowledge from videos, books, online publications, whatever, and then the group gets together. They say, yes, I'll bring you up to speed now regarding this topic. And then they say, oh, yeah, okay, that makes sense, or I didn't understand it. So you know what I mean? So everyone learns it even more deeply because it basically closes the loop.
I know what you mean. We just have to, that's just projection, because of course, for me, it's a fundamental moment in human history. I'm happy to weigh it up on such a grand scale because, of course, all the teaching is on the verge of an incredible transformation. And you just have to understand it because we come from this classic system, starting in school, people coming together, all the same age, moving forward year by year, and then at some point we're done. Some people do vocational training, some go to university, and others start working. And this system is being broken up, and it's important for me to understand taking it apart so deliberately, because it's only now possible to set it up this way thanks to technological advancements. And it's always the classic question, how do you evaluate that fairly when you have a group? It's not like before in school when it was just group work, right? It was always the same. Out of 5 people, 1 nerd did all the work while the others just coasted.
And then they played scat during that time.
Right? So, but as you said, you want to send the students out in a way that they can succeed in the business world, which is also fundamentally changing, to prepare them for that. And as you said, to address this group work problem so that everyone really develops the necessary skills and makes progress. And that's why I wanted to jump in again when you say, if someone needs information now, what does that actually look like? So how do they look for the information now? Did you provide an internal database with the AI tutor? Did you produce videos? Where are your materials? How should I imagine the student who now says, I have no idea, we're going to modify the MEO robot and turn it into a, I don't know, this or that. And now one of them has to say, okay, I need to create code snippets now. What do I use for that? Do I use Cloud Code, GPT Codex, or whatever? The next one says, I have to look at the robot arm from a biomechanical perspective. The next one has to create an alloy. How exactly do they get the information they need?
Exactly. So usually, on the one hand, it's like this. For most topics, we coaches give a brief introduction. And of course, we also give them information on where to find things, but we haven't handled that in a standardized way. So what I do is I have a lot of topics as instructional videos, and I say, here's my YouTube channel, here are some playlists that might be relevant for you. You don't have to work through all of them. You can just pick out the things that seem interesting to you. Here, these are books I've written, this and that might be interesting for you. And then they start doing research, and other colleagues do it differently because, of course, not everyone has their own YouTube channel. And some give more input. They say, okay, I'll come in 4 times and give them more input. I usually just spend about an hour and a half introducing them to the topic. I say, what are materials anyway? What could be of interest here? And basically explain the assignment. Because then they start taking the thing apart, first trying to figure out where everything is, where to even get the information from, what material it is, because depending on where the device was made, it's often not labeled. Then they get the idea. Yeah, can you check that somewhere? And then I always let them go on. Then I say, if you tell me how to check it, then I can see if we can do that here as well. Of course, I know how to check it, but they should figure out how to check it themselves. Then they say, yeah, we found out that you can do it with a DSC measurement. Then we could find out what kind of plastic it is. I say, what does this measurement do? They say, we don't know. Well, then go find out. When you understand it, come back to me. Then they say, yeah, it measures this and that. And if we see this and that there, then we can draw conclusions from it. Let's head to our lab and check it out. Or spark emission spectroscopy for metals. We also did all of that in the lab with them upon request. But because they came up with it and because they said, we'd really like to find that out, we'd like to understand what material is this, and then also be able to judge, does it actually make sense here? Exactly, but sometimes that happens, sometimes it doesn't.
What are your experiences since, as you said, it's so radically new conceptually? What are your experiences with the students at the beginning? How is the learning curve? So regarding working independently on things, this project-based learning, in the future, we'll work on projects and need information quickly. Everyone must choose their own way. We'll get to AI coaching as a boost, as an addition in a moment. How prepared are they at the beginning? Are they used to it? I mean, sure, we come from a YouTube generation used to learning from videos, but maybe you know it from experience too. Many have used videos and digital tools in recent decades just to get through exams. Yeah, in and out, and then move on. So what level do they come in at? How capable are they? How do you maybe even measure that?
No, so they arrive and the vast majority are not able to just start off on their own right away. That's why, especially in the first week, we basically do a project week where it actually starts with this personality test and to explain these roles, to run through a small project setup in that 1 week just to see, okay, in which direction should this go now? And of course, at first, everyone has a big question mark on their face. But the vast majority are super curious. What can I expect here? And of course, they see that. That has nothing to do with school as it still is in most cases. Of course, that also has nothing to do with college or university, like you might know from some Hollywood movies. Or unfortunately, how it still is in many places. And we also always have some individuals who drop out relatively quickly, because I have to say, I do see a problem that this concept can't work for 100% of young people either. Because you can only go all in. With a traditional degree program, you might have 6 modules in your first semester. And you can also say, well, I'll just start now and do these 3. Because maybe I'm already married, I have a child, I also have a job on the side, and so on. I would like to get this degree and continue my education. But it's actually unrealistic for me to do this full time right now. And that's just not possible here. But the people who go all in, they really live it. So you can, I mean, almost day and night go into these rooms and the people are there. Also, of course, partly adjusted to their own biorhythm. So some are already there around 8 o'clock and others don't show up until 10. But then they stay there until 8 in the evening. So it's very different.
As if I had written my book based on your course. I didn't really, shame on me. In the meantime, I hadn't been thinking about it nearly as much. But when we saw each other again in the live stream, you described all these things. Right now, memories from my book are coming back to me. Of course, it's a different story when you're talking about early childhood. Where do you still need structure? Where do you need basic skills? Reading, math, writing first.
How do you do it? I say yes and no. I just say yes and no. So you have to support them differently, of course. You have a completely different responsibility. Here, of course, they can approach it independently. Also, when it comes to the times and things like that, with children, it also has to fit into the reality of the family's life. That's not so relevant here now. But of course, they've never heard anything about materials before. But now it's actually relevant. Mechanics, they say, at least something. The kind of math you need here is suddenly a different one. And all these topics, or what have they already learned in physics? But now, all of a sudden, they want to understand the electric motor, like lithium-ion batteries and charging times. So they really want to understand all of that. And of course, you always need some input and also knowledge in order to develop competencies. Our big goal is competencies, and higher education pedagogy has been committed to that for many years. Unfortunately, I still see relatively little of that. But with concepts like these, you really get there. So you can say, okay, we're strengthening competencies. And the problem I see is that very few colleagues are willing to balance that out with content, so to speak. Yeah, because I can't just say this is the content they should cram into their heads, but at the same time, they're supposed to gain even more competencies. We all only have 24 hours in a day, yeah. And the question is, how much content do I really need to have ready at all, since it's available at any time? And how much of that realistically remains at the end of your studies? That was actually why, after a few years at the university, I started to question it myself. When I had my first students in their final exams, so to speak, in the graduation colloquium, and I asked them a question about the basic knowledge from the first semester in my subject, and then there was nothing left. But I think, come on. Yeah, so I taught there, I worked my arms and legs off, got great evaluations and so on. But what good is it all? If nothing really lasts in the long run, then I might as well save myself the trouble. Now, of course, you could say, okay, a basic way of thinking did stick. My mindset has changed. You have helped shape people into engineers. But still, why do I keep focusing on content if nothing from that content remains anyway? And yet I see that certain skills are required in the industry today, but they are not being addressed at all. For example, now with AI, where you're already quite active and trying to get it on track as well, I haven't done anything with that yet in my teaching setting, not even in a traditional degree program. And it's only in the last few weeks that I've actually started thinking about how I can integrate it there.
Let's stay on that for a moment because, of course, I'm also involved in this process of AI development. And we should mention it's now February 2026. And I also talk about this a lot in my presentations. AI is something new for many people. Those who deal with it know.
And that's why it's also a bit unsettling.
Always. New things are always unsettling, but I say the knowledgeable face the future more calmly. Quick wrap up. Already in the 1950s, people in the US were, of course, thinking again, artificial intelligence, how can we make these computers that are here now, how can we make them smarter? Then it took many, many decades. There was once an AI summer, then there was another AI winter. And fast forward to ChatGPT, suddenly we had artificial intelligence at our fingertips. Wow, it can write text, then it can generate images.
It was like in my childhood when suddenly the Commodore 64 was in every kid's room.
That's what it was like when the iPhone came out. A lot of people called it the iPhone moment.
Internet.
And just think about everything that's happened in the last 3.5 years. Breakthroughs like never before. And of course, I'm working on it myself right now. We're sitting here at a university that's completely digital, which is something different as well. Yeah, I imagine if you want to build the robot of the future for mowing or whatever, you still have to physically build it on site first, put it together and coordinate with others. But if you and I
still love grasping things in engineering. Yes, grasping them in the truest sense of the word. That's why I also have in-person classes in the traditional degree program. We still break things and hold them in our hands. Absolutely. Exactly these topics.
Absolutely. That's why it's such a good combination. If you have a degree program here in social media management, you can do it completely online.
Yes, absolutely.
Exactly. And even if you're currently getting a degree with you, you can also get a degree in, say, social media management at the same time, completely digitally. And we've now developed AI tutors in our own app. I'm currently in the process of bringing my entire math world from YouTube into the app. And then, yes,
That's not a small amount. No,
that's still a significant amount. It's still work.
because there are many thousands of videos.
Many people always say, yeah, AI, and there's ChatGPT, Claude, Gemini, and company. And then you input all that, transcribe the videos, take my scripts, and then use something called a rack system to train on internal data, create a database, and then match it perfectly so you don't hallucinate. And now I'm turning
To verified information.
to include verified data as training in order to have a coach that guides you both for the university internally, but also now, from my perspective, to contribute something to the world. To have a 24/7 companion that you can not only ask questions to, but who also interacts with you, who, as you said, doesn't just give you something like a recipe, but also guides you, suggests another snippet, the right video, the right PDF material, whatever it may be. And that brings me to a study. I also deal with studies from around the world. There's a very recent study from 2025 published by Harvard. They took about 200 physics students and held a lecture there, which wasn't a traditional lecture, but rather used active learning. As you mentioned, with coaches asking questions and having discussions in between, to a self-developed physics AI tutor that you can ask questions to 24/7 at any time during your learning journey, which is trained on internal data so you can rule out hallucinations. And it turned out that those who learned with the AI coach leveled up, learned better, faster, and learned more things in a shorter amount of time. Welch Wunder. Und da wäre jetzt die
I don't even know. I probably wouldn't have bet on that. Yeah.
But the question is, how do you design such AI tutors? You really have to think about that, and that's why you need people like you who come from traditional teaching and have experience with new methods in on-site teaching to develop such tutors. And now I'm wondering, what kind of boost would it be if in your concept, as you have it, and when you already send the students on their journey, you tell them, if you have questions, go look for the information yourselves. Now imagine if there was, I don't know, a TH Cologne AI coach that brings all these things together. I see, but it's true, you don't have that yet.
No, not like that. I mean, of course, we have a special version of chat that can be used freely and so on. Of course, you have AI-related data privacy issues and so on. Exactly. Basically, you can't train them in a personalized way either. So that's why I prefer to work with my own, because it knows me by now, of course. Yeah, so it always already knows what I'm getting at and says, should I make a script for a reel for you or whatever? So it knows what world I'm in and knows that I'm interested in materials related questions, that I'm interested in spiritual questions and so on. So it knows me pretty well. And that helps, of course. But I would say the difference for you is that you don't really need to generate the materials, but rather to modify them. You have thousands of videos. You have, I don't know how many workbooks you've already released, 30 workbooks, 5.
From grade school to university.
So exercises at every level too. That means, yes, right now, like you said, it's best to have the videos transcribed by AI so they can be inserted and so on. And then it can also reference, find videos or clips from videos, suggest them, or even convey this knowledge. I would also have a good foundation to do something similar. But of course, you don't just have that for every field of expertise. So if I were to take physics or something, we wouldn't have that yet. So there aren't any videos or extensive course materials and exercises that you could use to feed the AI.
I think that's a really exciting project. It's definitely something worth considering.
Yeah, you could at least get it started for materials engineering a little bit.
It's also said to be very clever when it comes to applying for funding. No, I really mean it, that you actually say, why isn't there money for this? I know this from my time as a student when I had to travel from my home state of North Rhine-Westphalia to Baden-Württemberg. In this sense, because that's where the research funds were available in order to, and that was before the release of ChatGPT, when we applied for and received approval to say, we use an AI system to match the transcribed videos based on a query with the appropriate section of authenticated, curated content. People are now saying, okay, when it comes to the future of teaching, there's a new concept from you guys here that really focuses on the whole topic. How will you have to work in the business world later on? Project-based, complex problems. That's it. Find the solution, come together as a team. Everyone looks for their information whenever they want, using whatever medium they choose.
And there are already companies that are definitely thinking in this direction.
Yes.
And now to say internal training, basically, or question pools with AI, yes.
Now to say, sure, you say there's no content for that yet. But I do think if you take your course now and say, okay, those things have to exist for physics. I bet they exist somewhere. Someone has already produced them, or someone will produce them, I swear. To then say you build it step by step, also on the side during development. Me and especially the AI coach who is there to support you, because I believe and I know, I'm sure that studies will prove that these AI coaches are developed step by step. And Harvard and MIT, the big ones, are already doing it. And I would like it if certain universities in Germany would also do this and pool their know-how. Again, with this curated data, whether in video form, PDF material, or whatever, to make it additionally available to the students. So I think that's super exciting.
No, I would definitely support that. And as you said, that's still a matter for the individual federal states in Germany. So I spoke with a colleague from Munich University of Applied Sciences last Friday. We also discussed my idea about the use of AI with him at the end. Then we thought we could submit an application together. But you can't just submit a joint application with a colleague from Munich, because most of the teaching-related funding is specific to each state again. And here, this computer game Welten der Werkstoffe, where we won the German Computer Game Award for Best Serious Game. The money I started out with back then was a DigiFellow grant from the Stifteverband. That also ran for a few years in North Rhine-Westphalia. Then that ran out. And as you said, Baden-Württemberg and Thuringia, they still have it because I'm on the other side of the process now. And so I've been sitting on the jury for the past few years because the jury shouldn't come from the same state to minimize the chance of any connections, which is all well and good. But that means I'm a little bit jealous because I see that, yeah, there are some okay ideas, but sometimes I think I would have better ideas. But I don't have any resources I can access to make something like that happen.
I don't understand that. I mean, not that sometimes
you just have to wait again and then.
Yeah, but that.
But yeah, but of course the waiting, because we have to, that's just how it is.
Waiting is over?
Yeah, but the thing is, unfortunately, that's still how education policy and funding work. It's not like I can say I have this absolutely brilliant idea. No matter what, even if I said I had the world's best idea for something technical, I still have to wait until a call for proposals comes out that fits exactly. And then the call for proposals comes out, and I once had one where you had to cooperate with Danube riparian states. That's right, at least 3 of them. I wonder who comes up with stuff like that. Who comes up with stuff like that? I mean, you have to somehow meet these formal criteria, but I think it should really be about the substance. Of course, I have to have a good concept, and someone has to look over it and say, yeah, this concept would really move us forward. And that's fine, but...
And I mean, I admire your path and your commitment from within the system as a professor at a university. Because I took the private sector path, and I also went through all the ups and downs from raising investment funds, pushing new things forward. And of course, I did the AI study with support.
Yeah, but it impacts you personally, which is why I admire you. You have to risk your own money, right?
Yes, absolutely.
Fortunately, I only use taxpayer money. The question is whether I get it or not, but for you, you raise funds.
Absolutely. I was just about to find a way to say that I'm a very persistent person and I keep going. And that's why I'll say it's also a bit of luck that I'm here now, also at a university that's only 5 years old, but is accredited. In that sense, it's a startup and can operate as one too. And my journey is now practically completed with my math course at Daniel Jung KI. Within this whole system, as we move things forward, it will become clear whether there is a business model or if it will still need support in the future. I will definitely keep going. And that's how it's always been. Startups, in that sense, basically, you're like a startup yourself in the university landscape, who take these paths but also test things out. Of course, mistakes happen too, but that's how you pave the way for the future. What would you say if, let's say, a university also wanted to take this path? How do I get started? How can a university with traditional lectures adapt for the future? What advice do you have?
Yeah, the thing is, we've already been invited by dozens of universities. So me, my colleague Stefan Benke, he's now the head of the degree program, and the other colleague Tom Tiltman. They get a lot of requests from other universities. They travel there and then report about it. But the problem is that, of course, many struggle with formal criteria and institutional constraints. And that's always the fascination. Wow, it sounds like this is really a big breakthrough, but this is something completely different.
But then give a tip on how to deal with this. But I mean, you can be radical.
No, I would say it always starts with having a handful of willing people. So people who say, we're really up for it, we really want to try something new now, and we're also ready to put in more than what's normally expected. Because in traditional degree programs, I sometimes have 500 people in a mechanical engineering lecture. I can't get them through with a concept like this. Instead, we have about 24 people, and that also takes time and energy. And of course, that's also something where the university administration has to go along and say, yes, we want to try this out. We are also willing to provide rooms for this. We are also willing to provide, for example, a research staff member, someone who, let's say, keeps everything together a bit, keeps an eye on communication and so on. I can't do that myself, nor can the colleagues I just mentioned do that. Therefore, this has to be supported by the university management and by the faculty where it is based. And then a few willing people need to come together and say, let's just get started. So it is possible, but that's usually the case. So you get some individuals excited and then they don't know how to get started, or let's say they don't have the authority to make decisions. So for us, it was also pushed forward by the dean at the time, Professor Langbahn. Our current president was the vice president for teaching at the time, who really pushed innovations forward in a big way. And of course, that's still a real showcase for our university. That means we take it around and show it off and say, look how great we are. The question is whether it's really that great and whether you're brave enough to keep rolling it out. Because universities, you also like to use the word transformation, but by that you mean the transformation of the school or university itself. What universities often mean by that is transforming society. And I say, okay, you want to transform society, but are you ready to transform yourselves? Yes, to transform yourselves. Yes, yes. But I just wanted to quickly mention that's because it's on a more practical level. Sure, but my idea about AI is not just how can I use AI in the university environment, but as we discussed, then the AI hallucinates. And how do I even write a prompt so that I get information out? How can I verify it again and so on? How much I need my own knowledge to be able to evaluate that and so on. And I say that's really a basic competency that you actually need as a graduate. And yes, we don't teach it. It's not planned. There's no AI module. And honestly, I don't even think an AI module would make that much sense. But I ask myself, why don't I just include it directly in a first semester module? And that I say after, let's say, about 2/3 of the semester, we meet in small groups and then I outline some parameters. And then everyone should use their AI to figure out which material you would probably need for that.
And I can tell you on top of that, because the development is really, I mean, I have rarely seen such leaps in development in such a short time in the last 25 years.
That's true. Yes, yes, absolutely.
Because on that topic, it's directly about if you can't come up with the prompt yourself, you can ask the AI to create the prompt for you. That's one thing. And the next thing is agent systems. That means, for example, with Claude, you say you have the main AI, and underneath that, you set up different agents. One researches material science, another researches, I don't know, studies. The next one looks into which paint I should use, and another does this and that. And building these kinds of agents. And that's basically a powerful tool for every student who now says, in the past, at least that's how I imagine it, in the past, as a student, you would go out and look for studies in books, always searching for information.
Now you can, I used to do literature research on microfiche.
Can you imagine
How many days that took?
And now you can run the master AI yourself with agents underneath in parallel as well. And of course, there are studies on that too. If you use ChatGPT, for example, do you get dumber? The question is how you use it. So I think it's good that you say you're considering implementing that right from the start to say, how do I use it? How do I prompt? What do I ask it? How do I set something up to create the prompt? But also the point that these agent systems are simply a great addition. And I believe
That's why, for example, I'm also thinking about who else I can bring on board because I don't see myself as the AI expert. I need someone, even if it means hiring an employee who understands this and can teach exactly these skills. Basically, I just want to collect what suggestions come in at first, and then I'll say whether it makes sense, and maybe we'll realize that some of them don't make sense at all, and so on. And then we'll look at what the different people are like. Why did he come to a better result than the other one?
And here I can already give a little tip to take away, especially for the younger ones. Get into agent systems now and start working with them because this field is so new. I can tell you this, whoever starts working with it now will be able to come to you in half a year and say, do you want to hire me? And you'll say yes, because no one else can do it. This is the golden age, and an incredible number of people really underestimate it. And there's one thing, there aren't any courses for it yet. It's all about learning by doing. That's just a tip.
Yeah, and I have a friend of mine. I've known him since he was a kid. I'm a bit older, and he's kind of the computer science whiz and always at the forefront. And then I was talking to him about AI recently, and he was raving again about all the new possibilities there are. And then I said, yeah, I tried different things, but it turned out to be total nonsense. He asked when, and I said about 6 to 9 months ago. Then he just dismissed it. Why did he do that? What was true 6 to 9 months ago isn't current anymore. He said, try it again today. You'll get completely different, much, much better results. Like you said, the development there is really massive. So AI itself is evolving, and of course also with technical help, it's advancing massively because the problems are being recognized, but now there are tools and ideas for how to handle everything. And I experience
again, how should I put it, that you also have to communicate it, of course. That society understands it. I also experienced that with my book. Sure, it became a Spiegel bestseller, and some people actually read it and engaged with it.
hopefully
Many others write recommendations there, often about the evil AI destroying everything, but that's not the case at all. It's about how you cleverly implement it, also from the teacher's perspective, so that you also say from the teacher's point of view, how do I use AI for support? From my workflow, from getting rid of things that can be automated so that you can focus on the child, on the student. And I think that's a misunderstanding that has come up, especially in the last 3 years, that people automatically say AI is bad and don't see the possibilities if you actually engage with it and use it correctly. And that's one of the reasons why we wrote it, to show people this is how you can do it. We also gave examples from a school in the US. If you take a look at them, that goes a bit hand in hand with the results you mentioned earlier, with those from your course who are now in industry, and then really from top companies.
they are accepted with open arms.
They are accepted with open arms. And that's already the case at this school in the US, where the kids spend 2 or 3 hours in the morning with an AI. They learn things, basically do research, and then subjects like math, physics, biology, the hard stuff. Then they learn so they can work together on projects again, still with people, with coaches, where they have to present and tackle applications. And then to the top 1%, to rank among the top 1% in the US. And my concern is that unfortunately this tends to drift into the private sector.
Because the social gap keeps widening.
Yes, because it doesn't reach the general public, because still, I think the misunderstanding is so big because everything is happening so quickly now. And after 10 years of digitalization, because it has already swept through the schools as well. Yes, and many have said, oh God, that's And now AI is coming in turbo mode. And I always say, take a deep breath, be brave, and try things out.
Yes, but our schools, they equipped 2 classrooms with whiteboards and got 30 tablets, and now they think they're digitalized. That's still the situation we're in today.
I don't want to complain. Like I said, I think it's good. I'm moving forward with a positive attitude.
It's okay, you're right, let's not complain.
I just wanted to quickly make the connection to gaming because that's another thing for you. You can't get kids away from games. Yeah, when kids play Fortnite and similar games, they're in it and you can't get them away. And it would actually be nice if it were the same in school or university, that you can't get kids away from learning. Yeah. That's why you should think about how to model the whole thing with a gamification approach. And you were also involved in that, you mentioned earlier, Welten der Werkstoffe. Maybe you can briefly touch on, just very briefly, what you did there.
Exactly. So the idea is that I'm teaching them different knowledge and skills chapter by chapter. But at the end of the day, they have to be able to assess a complex situation and stack all these building blocks of knowledge on top of each other. And then I thought, well, actually, that only works if I do exercises in parallel where the complexity slowly increases and then give feedback. But who is supposed to do that? So let's say 500 people and they each do, let's say, even just 5 practice exercises. That means I have 2,500 exercise sheets that I still have to correct. That's not possible. And then I thought a serious game like that, where they go through it chapter by chapter so they can basically play 10 or even 14 levels, the complexity increases slowly and they can make mistakes because no one is looking over their shoulder. The feedback is often actually funny, and they play their way through it and basically learn in a playful way whether they've already mastered it, what they're still missing, and then they also get the necessary hints there. And basically it turned into a classic point-and-click adventure. You play your way through parallel worlds in each level. You encounter another crazy version of Professor Bonnet, who is being kept from learning by the ex-matriculator, an evil figure. And you are Nicole Nickel, one of his students, who always helps someone and then gets a little piece of metal each time. The game starts with her having to take a materials engineering exam. And suddenly this Professor Bonnet up front, he looks so intimidating and says such mean things, and the exam is impossible to pass. She thinks something's not right here. She then goes to his office afterwards and finds out he's locked in a locker, secured with a futuristic metal analysis lock. And now she embarks on this journey to find the key, so to speak. Exactly. And the idea is simply to have this immediate feedback and making mistakes. Making mistakes is good and allowed. But when you said everyone likes to play, that was somewhat surprising feedback for me, because among the students, you have many who like to play, but not all. There are also comments that say, I don't like to play, I think it's silly. So that was like, oh, okay, I didn't expect that. That means it's just an add-on, it's not really necessary. And as a little motivation, they get 4 points. When they've completed it, they get a code word that's generated from their student ID number, for example, something like Rusty Owl. Then they write that on the exam. We check it, and if it checks out, they get another 4 points. But that's not an existing thing right now. But I always try to give more and more options. And you can use them, but you don't have to.
But I find it interesting because I would have expected that some people would say, no, I don't want that because I also don't believe that everyone is a gamer. But you still need to provide something for the people who are into that. That's just another add-on to say that at some point you say, okay, I'm going back to your new direction right now. You have a framework program there so that after a certain number of semesters, you're ready to go into the business world and work project-based, able to solve complex problems. And around that, there's this digital world where everyone, when they need information or have to learn something, can do it in their own way. One person more with an AI coach, another more with PDF materials, the next one through gaming.
Or in a personal conversation.
in a personal conversation, exchanging ideas. I think that's really exciting. It's happening step by step now, and of course, global developments are contributing to this, so it's moving more and more in that direction. And also in the development of the job market, which is now changing massively step by step. To ask what will you need in 5, 10, or 15 years to maybe start wrapping things up now? To take a look ahead, what do you think? You're probably a bit connected to the business world as well, pretty closely. What do you think will happen in 5, 10, or 15 years? Well, you can't really look ahead 15 years anymore. That's not possible anymore. But my question is, what will things be like in 5 years?
It wouldn't be fair to try to make a prediction about that.
Maybe something I'm often asked as well is, what are the future skills? What would you say?
Well, definitely agility and evaluation. So that I can evaluate solutions, see and recognize problems, because AI is coming, but it doesn't ask itself questions yet, not yet. So we don't have robots that walk around the production floor, then ask the AI and then suggest solutions and ideally even implement them themselves. That might be possible in 15 years. But the thing is, if I'm, for example, in a manufacturing company somewhere, I'm walking through the halls, and if I have an engineering mindset, I think, why are there always mistakes? And I realize we could actually do something better there. Then, of course, with AI tools, I can work out the solution much, much faster. Have entire construction drawings generated and send them directly to the fully automated CNC. The component is manufactured and someone installs it. But this ability to make trade-offs, meaning seeing problems, abstracting them, and already having a sense of direction, where do I actually want to go and what could the solution look like? And then, of course, the whole topic of interdisciplinary thinking is even more significant. So for a few years now, we've introduced an interdisciplinary project week, which is mandatory for many, many faculties. Simply because a mechanical engineer, for example, is surprised when he has to discuss something with a designer for the very first time in his life. He says, I don't understand you, and why do you want to approach it this way, and where are you actually going? But the fact that these worlds can actually communicate with each other, those are really the key facts for me.
I always say the key point of my keynotes is always this: learning is the core competency of the future. And many people understand that because many think learning is, I watch videos now and can do a bit of math, but learning is really also everything we've talked about today. You recognize a problem, you want to solve the problem, you come together as a team like that. And now we need the information we need for that. We have to acquire the knowledge we need. Where do we acquire it? How do we deal with a video? How do we deal with material? How do we use the AI coach? How do we communicate with each other? And the whole topic of AI, of course, because again, this is exactly the phase where we should be learning a lot. Where do we learn this now? How do we cope with the flood of information? Where do we find the information? Who gives me the right information about AI, agents, agent systems? Where do I find that? You should take care of that now to prepare yourself as best as possible for the future. And I always tell many people, take a look at your screen time. How often were you on TikTok or Instagram? I bet you can free up half an hour a day. And then look into that a little bit. AI models here, I don't know, new job fields there, opportunities over there. And whoever says that if you move forward like this in the next few years, you'll be able to go into the future feeling relaxed in the coming years.
Yes, and definitely gain some advantages.
Yeah, we've been at it for almost 70 minutes now. A lot has happened again, and I already have a lot going through my mind.
Yeah, me too.
We always have a lot of ideas, yeah, but ideas are shit. Execution is king. Maybe we can do something together. I could think about it, but for now, let's have another coffee and brainstorm for a bit. Thank you for visiting. It was really, really exciting again. And I'm curious if let's say, if we were to get together again in 5 years, I can hardly believe what will happen in these next 5 years. I bet we'll meet again sooner. Sit together again sooner.
On the one hand, that, and on the other hand, maybe we'll be able to look back with pride on some of the things we've already pointed out. Yes, yes, yes. And some things might embarrass us because maybe we were way too cautious with our assumptions about how everything could turn out. Yes. And hopefully some things will also prove us wrong. Yes. Well, I mean, I don't know how optimistic you are that our system as such will change, meaning the school system, the university system. I really hope will be proven wrong there.
Yes, we can only do our best. Martin, thank you.
Thank you, Daniel. Thank you.